Hello students. So today we will start with the new fresh chapter, that is friction. So let me write down the chapter name first. Okay. So we are going to start with the friction first. Okay. So first thing that we should understand is that what is friction. Okay. The first question that we should address here is what is friction. So the question that I want to address right now is what is friction. So many of you have different definitions in your mindset, okay, and many of you may be having the right answer only, but some of you might have the wrong misconception. Okay, like one of the misconception is that friction opposes the motion. Okay, friction opposes the motion. That is one of the biggest misconception that student has in their mind. Okay, this is not the case. Many times you will see that it is opposing the motion, and many times you will see that it is what supporting the motion. Okay, or you can say the cause of the motion is what the friction at that moment. Okay, so this idea or this definition that people have in their mind that friction opposes the motion is totally wrong. Okay, it's totally wrong. We can say we have to understand what is actually the meaning of friction, what is the actually the what we can say the cause of friction, and what is the nature of the friction. All those things we have to understand. So the first thing, that is what is friction. So guys, I will write like this way, that friction friction is the component friction is the component of the contact force that is acting that is acting along the along the along the surface of contact, or along the tangential direction of the contact of the bodies of the bodies of the bodies and it always tries to oppose the relative motion between the contact surfaces. Also, it tries to stop the possibility of relative motion, which is also known as, guys, what, impending motion, in its capacity. Okay guys, so this is, guys, what we can say is the uh, whole nature, behavior of what friction. Okay, what I am repeating again, guys, what, that friction is the component of the contact force that is acting along the surface of contact, okay, or along the tangential direction of the contact of the bodies. So first let's try to understand, guys, what, let's try to understand this portion only, that what does it mean. Okay, what does it mean? So guys, suppose if you are having a simple, like guys, if let's say you are having a body mass m plane on a rough surface, okay, plane on a rough surface. So guys, we know that if I apply some force, so guys, in this case, when you will see the contact force that you will be having between the body and the surface, it will be something like in this direction, okay. This will be what guys, your contact force. So like a lot of time people and the students confuses the contact force with the normal force. Normal force is not every time will be what your contact force. It will be the contact force only when there is nothing as a friction acting between the bodies. Then only the normal force will act like a what, contact force. But it is not always as the case, okay. So guys, here if I talk about, here actually there are two component of the contact force is there guys, okay. One is this, which you already know, which is what, normal force. And guys, there would be a force here, okay, there would be a force here, which is what, your friction force, if let's say the body is in motion or it has a tendency of motion with respect to what, the surface, okay. So guys, if you see, this is what, this is the surface of contact between these two bodies, okay. This is the surface of contact between these two bodies. And if you see, the friction force is what, acting along the tangent of these mutual contact of these two bodies, okay, mutual contact of these two bodies. So this is what guys, this is the direction. Maybe the possibility of friction is in this direction or in this direction, depending on the relative motion that we will see in the future in the later lectures. But right now you should understand that direction will always be what, along the tangent of the what, the contact surfaces, okay. This is the first thing that you should understand, that this would be the direction, okay. The one more case I can take for you. Let's say, suppose 1 minute, okay, let me show you something. Let's say guys, if you are having a body like this, okay, a rod like this. So here, if friction would act on the end A or end B because of the wall or the floor, the friction direction would be what guys, it would be either in or in this direction, depending on the motion type, or in this direction or in this direction, okay. I hope you're getting my point, because this is what, this is the mutual contact surface, and this is what, this is the common tangent that you could have here between what, these two surfaces, okay. So this is a very important thing that you have to keep in your mind, that friction force always acts along the surface of the contact, okay, along the surface of the contact, or you can say it will be along the what, tangent to the body. This is the first thing, okay. Now coming to the second part guys, the second part that I was discussing is what, it always tries to oppose to the relative motion between the contact surfaces. Also, it tries to stop the possibility of relative motion, okay, which is also known as what, impending motion, technical term hai, okay. This is a technical term guys, okay, the known as what, impending motion in its capacity, okay. So whatever its capacity is there, it will always try to what, try to stop that motion if it is in it's in capacity. If it is not in its capacity, then the relative motion will start, and then a friction will go, it's up to a certain capacity, and then what, motion will happen, okay. But till its capacity, if it is there, it will try to stop that impending motion. I hope you are able to understand that thing, okay. So guys, what does it mean? Let's try to understand this also. So guys, let's try to understand this relative motion thing, okay. What is this relative motion thing? So suppose guys, if you talk about the direction of friction, okay, so I'll just write down as a heading that direction of friction, okay, because people have this thought in their mind that it is always what, opposite to the motion of the body, but that is not the case, okay. Like guys, if you see, suppose if you are having a surface, okay, and there is a body here, okay, there is a body here, and this body let's say mass m, whatever you want to call it, okay, and I am putting another block lower here guys, and this is what, let's say capital M, okay, and this is what your ground. Okay, now guys, suppose if I ask you, let's say this velocity is what 4 meter per second, okay, and this is what 3 meter per second. So if I ask you that what is the direction of friction force on the upper block. So guys, many of you who have this kind of a perception in their mind that it will be always what guys, it is always in the opposite direction of what the body's motion, then they will say, sir, it will be what, it will be in the back side. Okay, it will be what, in the back side. But guys, actually if you see in this case, the answer will be what, it is going to be what, in the forward direction. Okay, it is going to be what, in the forward direction. So how it is happening guys, try to understand. Okay, so see, who is going to apply the friction force guys? Of course this body is going to apply the friction force on this one. Okay, it is going to apply the friction force on this one because that is the contact. Okay, so if anybody is causing the friction force or anybody is applying the friction force, that would be what, this lower plank. Okay, that would be what, this lower plank only. So try to understand when and why it applies this force. Okay, so guys, see here, if you see the velocity of this is what, 4 meter per second. So whenever you have to understand the direction of friction force, what you do, you should see you should do this thing simply. Okay, what you do, you sit on the body from which the force has to be applied on the other body. Okay, so if you sit here, what you will see, the relative velocity of this upper block guys, that will be what, that will be, you know, that velocity of upper block, okay, with respect to u. Okay, that is what is, that is velocity of upper block. Later I will tell you the my method. Okay, and you will be like never to be worried about all those things that I am doing right now. Okay, so velocity of upper block minus velocity of what, the plank. Okay, plank. So guys, see, okay, so velocity of upper block is how much guys, 3, and this is how much, 4 in the same direction. So 3 minus 4, that is what, minus 1. So the relative velocity that we are seeing guys is what, in this direction, that is what, minus 1. Okay, that is what, minus 1. It means if this is the direction, of velocity, relative velocity, so guys, it means this one applies the friction force what, to oppose the relative velocity. What I did say in the definition, that it opposes the relative velocity. So it means it will apply the friction force in which direction, in this direction, which is what, which is opposite to this relative velocity that I had shown earlier. Okay, that this relative velocity is how much, 1 meter per second I have gotten. So it will be the relative velocity with respect to the plank. So guys, just let me write down this for you. Okay, so if you see, this is guys, okay, I'll just show, let me take some other color. Okay, so guys, this is the relative velocity of this block, upper block, with respect to the plank. So the friction that will be acting on this block F, okay, will be what, in the forward direction. So this is the direction of the friction force. I hope you understood how to find out the direction of friction force. Okay, so another method, okay, alternative method that I felt that this would work, and I have seen that yes, it works, because like I have tested this thing many times, and I feel that this idea is very good. Okay, so guys, alternative method. Okay, and you can say, I don't know, like maybe other teachers also would be following something similar, but this is the my idea that I have like made. Okay, and I feel that this would be very very like handy for finding the friction force, guys. So what I say, just listen guys, that as I am right now, I want that you should also become like that. You should also become like that. Okay, you should also become like that. This is the simplest idea that we have to use. Okay guys, so with this idea you can find out the direction of friction force in a seconds. Okay, so if you see guys here, if I take the same picture, okay, if I take the same picture and then I discuss with you, you will see that how easy this one. Okay, so let me just make this figure again guys. Okay, so if you see, this is your block small m, and this is capital M, and this is what, having a speed of how much, 3 meter per second, and this is having a speed of what, 4 meter per second. So guys, if you see, who is going to apply, the lower plank is going to apply. Okay, means I am the lower plank. Okay, I am the lower plank, and I am going to apply the force on you, means the upper plank. Okay, so if you see, my speed is how much, 4 meter per second. My speed is what, 4 meter per second. So what I will be wanting to, what I will be wanting, I will be wanting that your speed should be also what, 4 meter per second. Your speed should be also what, 4 meter per second. To make it happen guys, what I will do, I have to apply the force in which direction guys, I have to apply the force in which direction, simply in this direction. Okay, I have to apply the force in what direction, in this direction. And you can see, with this simple idea, I can find out the direction of what, friction force. And you can use this idea for any kind of this kind of a problems where relative velocity is there. Okay, and you can find out the direction of friction force. I hope you understood this idea. Okay, so guys, we have discussed what is friction force and how do we find out what, the direction of friction force. Okay, how do we find out the direction of friction force? Let me take an example, one more example, to show you that how do we find out the direction of friction. Okay, so just let's see, I'll take multiple blocks for you. Okay, so guys, suppose this is block 1, block 2, block 3. Okay, let's say this is, I'm calling A, this is B, and this is C. Let's say this is moving with 4 meter per second, this is moving with 2 meter per second, and this is moving with what, 3 meter per second. Now if I ask that what is the friction force acting on A, well, like what is the direction of friction force guys? So if you see, for block A guys, okay, there is only one surface of contact is there, means B is only going to apply the friction force. Is this okay or not? Okay, so if you talk about the block A guys, okay, if you talk about the block A, the friction force, because if you see the B is going to apply, means I am become what, B, and you become what, A. So I will see that what is my velocity, my velocity is 2 meter per second, and your velocity is what, 3 meter per second. It means your velocity is more than mine. So what I will try to reduce your velocity. So to reduce your velocity, I will apply the friction force in which direction, in this direction. So that will be what guys, that will be F on A because of what, B. Okay, F on A because of what, B. So that is the direction of what, friction force on the block A. If you talk about guys what, block B, okay, if you talk about the friction force on the block B, so guys, because of Newton's third law, we know that every force comes in the nature in the what, in the action reaction pairs. Okay, so if FAB is acting on here, so this will be what, this will be minus FAB or FBA. Okay, we can say this thing. Okay, now coming to the friction force on block B because of what, C. Friction force on B because of what, C. So guys, now because I have to apply from C, means I am become C and you become what, B. So I will see first my velocity is what, 4 meter per second in the rightward direction, and your velocity is what, 2 meter per second only in the rightward direction. So your velocity is less than mine, so I will help you to increase your velocity. So what I have to do, I have to apply the force in which direction? In the forward direction. So I will apply the force in forward direction, and that will be what, guys? FB because of what? C. Okay, that would be the direction of what? Friction force. That would be the direction of what? Friction force. Now coming to the block C. Okay, coming to the block C, guys. So if you talk about, guys, block C, so on block C, as Newton's third law we have just discussed, okay, the force because of block B on C will be what, guys? That will be minus FBC here, or it will be what? FCB, we can say. Okay, FCB. That would be what, guys? That would be your direction of friction force acting on the block C because of what? B. Now coming to the block C because of what? Ground. So guys, you know that ground is at what? Ground is at rest. Ground is at rest. Okay, because everything we are discussing in the frame of what? Ground only. So it is what? 0, and C is what? 4, and it is what? In the forward direction. So ground will apply the force of friction in this direction, that is what? F on C because of what? Ground. Okay, F on C because of what? Ground. I hope you understood, guys, the idea of what? Finding the direction of friction force. Okay, so that's it for today. We'll see in the next lecture. Okay, thank you.